In this video, we are going to proceed with the simple linear regression model and confidence interval. Regression is a statistical method used to describe the nature of the relationship between variables, where it can be positive or negative, linear or nonlinear. So for example, we have linear regression, polynomial regression, and logistic regression. But for our case, in this course, we will only learn about linear regression. A linear regression is an approach for modeling the relationship between a scalar dependent variable and one or more explanatory variables, or we call it as independent variable. So dependent variable usually denote by y, and independent variable is x. This is denoted as y and this is denoted as x. So for example, is the simple linear regression and then multiple linear regression. But for this course, we will only learn about simple linear regression. So before we proceed with the simple linear regression, so let's find out what are the meaning and the definition of the residual, where residual is the vertical distances between points on the data set and the fitted line. And marginal change is the magnitude of the change in one variable when the other variable changes exactly 1 unit, or simply the slope beta of the regression line equation. So a simple linear regression is a linear regression when there is only one explanatory variable. So one explanatory variable refers to the one independent variable. The simple linear regression fits a straight line through the set of endpoints in such a way that the sum of squared of residuals are at least as small as possible. So the equation for the simple linear regression is given as y hat equals to a hat plus beta x. So why we use y hat? Because it is the predicted value of y, given y is the dependent variable in a regression equation, where alpha hat is the y hat intercept and beta hat is the slope of the line. So we will use the method of least square, where this method is used to estimate the regression coefficient, which is the y hat intercept, alpha, and the slope of the line, b hat. In this method, the square of the vertical distance of data points from the fitted line is minimized. So this is the method of least square. So there are two ways on finding the alpha hat and the beta hat. Given this is the first way, okay, where alpha hat is given as the summation of y times with the summation of x squared minus the summation of x times with summation of xy divided by n times with the summation of x squared minus with the summation of x and squared this value. And this is the formula for the beta hat. Okay, now we have found the value of alpha hat and beta hat. Then we can get the value of the regression equation, given the regression equation is y hat equals to alpha plus beta x. Okay, and another method, another way to find the alpha and beta is we find the alpha given that it is equals to the average of y minus with beta hat times with average of x, given that the beta hat is equals to xy divided by sxx, where sxy, the formula of this is equals to the summation of xy minus with the summation of x multiplied with summation of y divided by n, and this is the formula for sxx, and this is for syy. So you have learned how to find this in your previous topic in correlation, okay, and also the summation or the average of x is given as summation of x over n, and this is the average for y. So you can either use the first method or can use the second method in order for you to find the value of alpha hat and beta hat. So here given this point is the observed value. This is our observed value, and the predicted value given the y hat, which is obtained from the regression equation. Okay, this is the predicted value. So the difference between the actual value, okay, the observed value of y, and the predicted value, okay, that is the vertical distance, okay, here given as this, is called as a residual or a predicted error. So the residuals are used to determine the line that best describes the relationship between two variables. So the reason why you need a line of the best fit is that the values of y will be predicted from the values of x. Hence, the closer the points are to the line, the better the fit and prediction will be. So when r is positive, it means that the line slopes upward and to the right. And when r is negative, the line slopes downward from left to right. So here we have learned how to find the value of the r, okay, based on the two methods used, which is Pearson and Spearman. So the regression line determined by these formulas is the line that best fits the points. The sum of squares of the residuals computed by using the regression line is the smallest possible value. For this reason, a regression line is also called as a least square line. And the regression line will always pass through the mean point. Right, so now let's try this example. Given the following data represents marks obtained by 10 students in test 1 and test 2. So the question is to find the fit a linear regression model with test 1 as explanatory variable and test 2 as dependent variable. And the second question, predict the score a student will obtain in test 2 if he scored 60 marks in test 1. So given from this first equation, let's identify the x and y value. So given test 1 is the explanatory variable. So explanatory variable means it is independent variable, which means that it is denoted as x. So the y would be the dependent variable. So dependent, which means that it is y. Why is it dependent? Y is called as dependent because y equals to alpha plus beta x. So given that this y depend on the value of x, so and x is independent because it doesn't need any values, okay, or any variable, so which means that it can depends on it, it can be independent. Okay, so that's why x is called as independent and y is called as independent. So here, to find the fit, the linear regression method or model, we need to use the formula from the method of least square. So in order to find the alpha and beta, you can choose which procedure you want to solve, okay, but for this question I'm going to show you the first method here. So first of all, identify all the value of x squared, y square and xy. Okay, and then so these are the value of xy. Given xy is 65 times with 68, and for x square it is given as 65 square, y square is given as 68 square. So we get all this value and find the summation for each column. Okay, and then now we proceed with finding the alpha. Given that the alpha hat is this formula, so just substitute the value of this into the formula and you will get the value of alpha, which is equals to 12.31. Next, we find the value of beta hat. Given the formula is this, and you will get the value of beta, which is equals to 0.82. So now we have obtained the value of alpha and beta, and now we can just substitute into the regression model. Given the regression model is y equals to alpha plus beta x. So alpha is given as 12.31 and beta is given as 0.82. So this is our linear regression model for this problem. So now we want to solve the second question. He predict the score on a student who obtained in test 2 if he scored 60 marks in test 1. So given test 1 is x and test 2 is y, so which means that we want to know the value of y when x is equals to 60. So we just substitute the value of x equals to 60 into the regression model. So we get 12.31 plus 0.82 times with 60. So which means that the test 2 will be equals to 61.51. So now let's try out example 2. Given the following data obtained from the study of age and blood pressure. So given we have person A up to F, which means that we have 6 persons, and the age given that this is the dependent variable and pressure is given as independent variable. So now we want to find the equation of the regression line for the data and then predict the blood pressure for a person who is 50 years old. So I'm going to show you using the second method. Okay, you can try out by yourself, okay, and compare the answer or your solution with mine. I'm going to use this formula to solve this example. So first of all, I have identified all the values of xx and yy and xy. So now I want to find the value of beta first because we need to know the value of beta first in order for us to get the value of alpha. So beta is given as sxy over sxx. So first find the value of sxy. So given sxy is equals to the summation of x y minus with the summation of x times with over n. So here would be 47634 minus with the summation of x 345, summation of y is 819 divided by 6, which is equals to 541.5. Next, finding sxx, which is equals to the summation of x squared, summation of x squared and n. So summation of x squared is given as 2399 minus with summation of x is 345 squared divided by 6, 561.5. So beta is given as divided by, which is equals to 0.964. Okay, so now we want to find the value of alpha. So alpha is given as the average of y. So average of y is given as the total of y divided by the number of samples, which we have 1, 2, 3, 4, 5, 6, minus with beta 0.964 times with the average of x, which is 345 divided by 6, and we get 81.07. So which means that our regression model is given as equals to alpha plus beta x 0.94x. So now we want to predict the blood pressure for a person who is 50 years old. So given 50 years old is the age, which is x equals to 50. So now we just substitute into the model. So we get 81.07 plus 0.964 times with 50, and you will get the pressure, which is 129.27. So which means that a person who is 50 years old have the blood pressure of 129.27. Try this out. Now we will proceed with the hypothesis testing in simple linear regression, where we test the slope is not zero. So in hypothesis testing, we want to test the existence of linear relationship between any two variables x and y. So the first step is we have to set up the hypothesis. So given h naught is given as beta equals to 0, and h1 is beta is not equals to 0. So beta equals to 0, which means that the model reduced to y equals to alpha, which implies that the value of x have no effect on y. So there is no relationship between the two variables. So beta equals to 0 refers to there is no relationship between the two variables. And we will reject h naught when the t-test is greater than t alpha over 2 and minus 2. So we will use the t-test for the hypothesis testing in simple linear regression. Then the next step is to calculate the test statistic. Given that the t-test is equals to the value of beta over the square root of variance of beta, where variance of beta is equals to SYY minus beta times with SXY over SXX times with n minus 2. So that is how we find the test statistics for the hypothesis testing in simple linear regression. So now let's proceed with examples so that you can understand more how to find the hypothesis test. So example 1, given the dosage of a stimulant drug and the reaction time to a stimulus are recorded for each of several subjects injected with the drug. So given the dosage is denoted as the independent variable, which is x, and the reaction time is y. So now, is there any evidence that the linear relationship between dosage and reaction time among the subjects injected with the drug? And conduct an appropriate test using 0.01 significance level. So here, this is our keyword, okay? Evidence that the linear relationship. So we want to see whether it follows the linear relationship between these two variables or not. So for this case, we will use the hypothesis test for linear regression model. So first of all, we will identify all the values of x, the total of x, total of y, and then you have to know the value of sxx, sxy so that you can find the t-test. So now let's fill in the table here. Okay, now I have calculated the value of sxx, syy, and sxy. So the value of beta would be negative 35 over 40, which is negative 0.875. So we have determined the value of beta. Next, to find the value of alpha would be the average of y, which is 32.8 divided by 8, minus with beta, negative 0.875, times with the average of x, 56 divided by 8, which is equals to 4.713. Okay, so that is the value of alpha and beta. So now we have found the value of alpha and beta. Next, we can determine. So the first step is to determine the hypothesis, given that the null hypothesis is beta equals to 0, which means that there is no relationship between, there is no linear relationship between x and y, and the alternative hypothesis would be beta is not equals to 0. So the second step is calculate the sample test statistic. So given the formula for t-test is equals to beta over square root of variance beta. So given the formula for variance beta is equals to this. So we just substitute all the values we obtained in the previous slide, syy, beta, sxy, and sxx into this formula and get the sample test statistics. So now we have identified the value of variance beta, which is equals to 0.01. Next, just substitute into the t formula. Given beta is negative 0.875 over the square root of 0.01, which is equals to negative 8.75. Okay, so this is our t-test value. So now determine the critical value given using t alpha over 2. Alpha is given as 0.01 divided by 2, and our n is given as equals to 8. So 8 minus 2 would be equals to t 0.0056. So which means that this is our column to find. Okay, so here 6 would be 3.707. So since it is a two-tailed test, so it will be plus minus 3.707. So the next step is to make decision. So given our t-test is equals to negative 8.75 and the critical value is given as plus minus 3.707. So negative 8.75, which means that it falls in the rejection area. So since the value of t-test, which is equals to negative 8.75 less than negative 3.707, where this is the critical value. So which means that we have to reject H naught. So we make conclusion that there is evidence, there is enough evidence that there is linear relationship between dosage and reaction time. Okay, so that's it. So the last topic for the hypothesis testing of the linear regression is using ANOVA approach. So this is the ANOVA approach. Given this is the source for the regression, and then this is within error, and this is for total. So the sum of squares for this one would denote as SSR, for the within or error as SW, and the total would be SST. And the degree of freedoms would be always equals to 1, and this one is n minus 2. So 1 plus n minus 2 would be n minus 1. So the mean square of this would be, for the mean square of regression would be SSR divided by 1. And for the mean square of within, it will be SSW divided by n minus 2. So to find the f-test, it will be equals to the mean square of regression divided by the mean square of within. So how can we find the value of SSR and SSW and SST? So SSR is equals to the beta times with SXY. The SST is equals to SYY, and the within can be found by taking the value of total SST minus with the sum of square regression. And the hypothesis would be just the same, where there is no linear relationship between two variables, and the alternative hypothesis would be beta not equals to 0. So we will reject H note when the f-test value is greater than the critical value given f alpha 1 and n minus 2. So now let's try the first example on how to find the linearity of regression using ANOVA approach. So this is the example, okay, where the data obtained from the study of age and blood pressure. So using ANOVA approach, test to determine if age is linearly related to pressure using significance level 0.05. First, let's identify the SXY and then SYY, and also we also have to know the value of beta. So SXY would be equals to summation of XY minus with X and Y over N. So given N is 6. Which is equals to 47,9634, and then 345 times with 4819 divided by N, which is 6, and you get the value which is 541.5, and then the value of SYY would be 112443 819 square over 6. 649.5, and SXX would be equals to 2399 minus 345 over 6, which is equals to 561.5. So from this value, we have obtained the SXY and SYY, but we need to know the value of beta. So beta is given as equals to SXX over SXY over SXX. So this one I use the first method in the method of least square. So this one would be 541.5 divided by 561.5, which is equals to 0.9644. So now we can proceed with our sum of square of regression, which is equals to 0.9644 times with SXY, which is 541.5. which is equals to 522.22, and our sum of square of total is equals to SYY, which is 649.5. Now I have write all the values into the table. So within the sum of square for error can be obtained by find the difference between 649.5 with 522.22, and you will get the value, which is 127.28, and the degree of freedom for this one will be n minus 2, which is equals to 6 minus 2, and the mean square will be 522.22 divided by 1, and you will get 522.22 for the mean square regression. And for the mean square of within, it will be 127.28 divided by 4, which is equals to 31.82. So therefore, the test value would be 522.22 divided by 31.82, which is equals to 16.41. Okay, now this one will be 1 plus 4, which is equals to 5. Okay, now we find the critical value. Given the critical value is f alpha 1 n minus 2. So given alpha is equals to 0.0514. So using the table, you will get the critical value, which is 7.71. So if we try to plot this, 7.71 is our critical value, and the f test is given as 16.41, which lies in the rejection area. So we can conclude that 16.41 is greater than 7.71. So we need to reject H node, which means that there is a linear relationship between H and pressure. So this is the formula to find the confidence interval on the slope for beta. So given the formula is beta plus minus t alpha over 2 and minus 2 times with the square root of the variance over sxx. So that is how we find the confidence interval on the slope. And this one is the confidence interval on the intercept. So this is the formula for alpha plus t alpha over 2 and minus 2 multiply with the variance times with 1 over n plus the average of x square over sxx. So given the variance is equals to this formula. So that's just the overview of the confidence interval for the intercept and the slope. Right. So this is the end of the chapter. Thank you.